let's work through this old exam question about free fall motion or projectile motion. You need to first try it yourself. Download the question from the link below. And don't forget, while you're at it, to like and subscribe and visit my website, www.learnscience.co.za. So first we're told that somebody throws a stone up from the top of a high building, and we're asked to find the maximum height that it reaches above the ground. Now we need to first understand what's going on here. This is an example of free fall or projectile motion. What does that mean? Free fall is the motion a body undergoes when the only significant vertical force acting on the body is gravitational force. In other words, is the weight of the body. Now you might think that when the stone leaves the thrower's hand and moves upward, it's not in free fall. It is. Why? Even though it's going upward? Yes, even though it's going upward, it's still in free fall. Why? Because after it has left the thrower's hand, as long as there is negligible air resistance, which we're told is the case, the only significant force, the only force acting on the stone is its weight, gravitational force, down. And so it is accelerating in the direction of that single, and therefore net, force, down. Even though it's moving up, it's accelerating down. When acceleration and movement are in opposite directions to one another, then the movement gets slower and slower. And that's what happens here. Watch this movie here to help you to understand projectile motion better. But let's move on to the question. So there we have the ball being launched upwards with a velocity of positive, meaning upward, 10 meters per second. And that is from the height of the building, the top of the building, which is 40 meters above the ground. Now let's reproduce this section over here, a diagram just for this interval for this question. We have the initial velocity of positive 10 meters per second, meaning 10 meters per second upward. This is the interval being asked about here. For that interval, the final velocity is 0 meters per second because the stone stops for an instant right at the top of its motion. We don't know the time duration of this interval. We don't know delta t. So that eliminates these two equations. But we do need to find delta y. We don't know it yet, but we need to find it. If we look at that equation, we then know Vf, Vi. We're trying to find delta y, but there should be only one unknown value, so we should know A. In this case, it's g, the acceleration due to gravity, because this is a projectile. In other words, it's in free fall. And what is g? Well, it's downward, so it must be minus 9,8 meters per second squared. So all we need to do is to substitute into this equation and do our algebra. Make sure that you do put in the signs. So we find delta y to be 5,10 meters. But be careful, that is not the answer to the question, because we were asked how high above the ground is the maximum height. Now this interval here, remember, is actually all up here. And so we still need to add this 40 meters. So height above the ground is equal to 5,10 plus 40 meters, which is obviously 45,1. And before we go, have you already liked? Have you subscribed? Have you left me a comment? And please go and visit my website. You'll find a lot of resources there, and they're categorized in a way that will make it very easy for you to find what you need. Until we meet again, learn science!